Now let's do the other table. We have those two-dimensional points, the distances between which we want to calculate as well. Let's take the x and y coordinates and let's give the name x and y this time. This is a bit different, the calculation of those distances. Formulas, create from selection, top row again. So this block will be x and this block will be y up on the left side. Okay, now let's go and write number 1 in here, 2 in here, and let's copy them together so that Microsoft Excel will take the pattern and have our numbers from 1 to 27. Let's do a copy and let's do base special in here, and we do in transpose again, and here it is. Now we have nicely points that are numbered by just sheer numbers, 1, 2, 3 to 27, 1, 2, 3 to 27, and here they are. Okay. Now we would like to calculate now. Remember, before we calculated Hamming distances, what we can say about Hamming distances is that it just calculates whether there is a difference or not. So it kind of abstracts away from, or it kind of doesn't take into account the largeness of the difference. Okay, but now with those points, x and y points for the 27 operations, we want to do Euclidean distances, so we measure the straight line distance between the points. Let's do this once again like this. We take those points and we do insert and scatter graph. Here we are. These are our points, pixels, and we want to calculate all the straight line distances between those points, like all the straight line distances with Euclidean distance. Okay, it goes like this. The distance between the first and the second point equals SQRT square root, and now we want to do delta x, double parenthesis, and we want to take the first point's x coordinate. So its index takes some kind of a point out from the x's, and we do index x's x comma index x comma, and now we take the first x. Here it is, and we close parenthesis minus index x comma the second point. So we once again are going to be using those headers on the up and left side, and we just take with index the first point's x coordinate, and with index the second point's x coordinate. We put a parenthesis around here as well, so we kind of take the difference between the two. Remember that there was a double parenthesis in the beginning of square root as well. We take the difference and we square them. So we want to do this squaring sign. It's Alt. You have to hold Alt key and then to 94. Alt 94 and 2. Then it's to the power 2. Okay, let me just enter this formula for a second. Let's see if everything goes right. So it's SQRT double parenthesis index x 8031 minus index x AF 30 to the power 2 to the power 2. So this is one x coordinate, this is another this is the difference between the two, so it's the horizontal difference, or delta x, squared, and we get the square by clicking Alt and 94 and then releasing Alt from the right side of the keyboard, and then we get the difference between the x's. And now we have to actually, inside this SQRT, so inside the square root, we have to add another such thing as well. So it's again index y's and 8031 minus index y's and AF30. We close the parentheses, we close them again, and we do an Alt 94 and to the power 2. I think I didn't remember to put parentheses in the beginning, but now it's okay. So here it is. It's two x coordinates that are subtracted from each other. It's two y coordinates that are subtracted from each other, and to the power 2 to the power 2. So the horizontal and vertical differences are squared, they're added together, and square root is taken. So this is it. This is the straight line distance. Now we have to put those dollar signs. So 8030, the green one, will have 80, I mean dollar before AD. AF30 will have before 30. 8031 will have before AD. AF30 will have before 30. So this is it. These are the dollar signs we're using. Now we can copy this thing all over the place. Let's make this whole table visible right now. Okay, and let's copy the formula. And here it is. We have calculated all the distances between the two-dimensional points.